Hey everyone, welcome to the Tom's Hardware Podcast for May 10th, 2022. As always, I'm Tom's Hardware Editor-in-Chief Avram Piltch, and I'm joined by Associate Editor Les Pounder, Raspberry Pi expert Ash Hill, and our very special guest, Jeff Geerling, whom we've had on before. And he has been doing a lot of experimentation with the compute module 4, figuring out new things you can do with it. And he's had a breakthrough that we've been waiting for he's been working on for what, a year or 2 years?
Yeah, it's been almost 2 years, 18 months or so.
So tell everyone about this amazing breakthrough.
So when the Compute Module 4 came out, I actually don't have it with me because I'm working on a ridiculously awesome project that I'm recording tomorrow. And it's in a different room right now because I couldn't fit the thing I'm working on in this room. But anyway, the Compute Module 4 has a little PCI Express slot on it. And graphics cards use PCI Express, and a whole lot of other cards use PCI Express. So the first thing I wanted to do was, can I get a graphics card working on it? So I plugged one in and it didn't work. It could recognize the card, but it didn't work. And that started a very long journey and probably has involved at least 30 or 40 people at this point. Probably more than that, but 30 or 40 people contributing to the conversations across GitHub, across the Pi forums, across my website, the blog comments, across YouTube video comments, Twitter, IRC. I don't know where else this was discussed, but there were so many different things that people were saying, like, oh, gee, have you tried this? Have you tried that? Have you tried the older generation NVIDIA cards and older AMD cards, newer AMD cards? Through the course of it, we found so many different things. Like one thing was parts of the Pi kernel, the Linux kernel that runs everything on the Pi, weren't working correctly for PCI Express. So some of those things were fixed, like MSIX interrupts. I'm not going to get into what those are because I barely understand them, but that wasn't working. Now it is. The bar space, there's a way that the kernel maps memory between devices like video cards and the RAM on the system so that you can store data for your hardware when you're bringing up a video card or a storage controller or whatever else you plug in. So bar space was too small, so they actually made that bigger. So now you could use pretty much any graphics card supports the amount of bar space the Pi comes with by default now. So they fixed that issue. I think there were a couple other patches in the Linux kernel that Raspberry Pi uses that have gone in to help. But there was always this one big problem, and that's that the actual hardware that's not only on the compute module, but the same chip on the Pi 4, it's the BCM2711 from Broadcom that Raspberry Pi uses. This chip actually has a few broken things in the way that it has PCI Express. And so our goal for the past year and a half now has been, is there any way we can work around that in the driver? The biggest thing that's broken is 64-bit memory accesses do weird things. So especially user CoreForge on GitHub. I forget who else, Phil Elwell from Raspberry Pi and some engineers from AMD chimed in. We all worked around these issues and we finally got a display working through a graphics card on the Compute Module 4 using an AMD graphics card, using an older driver because it was simpler to work with that older driver. It's not like you can just use a Raspberry Pi for mining Bitcoin or you can use a Raspberry Pi for all these other things. With the graphics card, there's a lot of parts to a driver, and we got some parts working. So we have a little bit of 3D acceleration. We have the display working. We can have the console go through it. We can run some things in X Windows, Xorg. We can kind of run Wayland a little bit. So right now, the thing that we're working on as of today is seeing if we can get Box86 to run Windows games like Portal 2 through the GPU. And right now, CoreForge is working on that. I actually just sent him last week a Compute Module 4 with 8 gigs of RAM because these things are so hard to find. I think I have probably like 50% of all of them in the United States. So I sent one of mine over to him over in Europe, and he's going to start working on it. And because one of the problems is if you have lower memory, you can't do some of the things that you might need to do to hack the drivers for it.
Wow, that's wild. So, what is the best graphics card that it can work with currently?
Right now, the best one I've used personally, and the best one I've seen anybody use that still works with the AMD Radeon driver. AMD still makes Radeon graphics cards, but the Radeon driver that they used in Linux, it's an open source driver, which is nice because you can actually modify it and make it work, unlike NVIDIA's drivers, which have closed source. Um, so the latest one I used was a 7450, I forget what the exact model is, but it's the 7000 series Radeon card, HD 7450 or 7350, or I don't know. The numbers, the way that people name things is ridiculous. But anyway, it's that series, which isn't a terrible card. Like if you're comparing it to the Pi's built-in graphics, it's comparable and faster in some ways and slower in other ways. But it's like 3 or 4 generations old at this point. So around the time that the next couple series of graphics cards were introduced, AMD switched over in Linux to a new driver called AMD GPU. So initially I started working on the AMD GPU driver, but not as many people have newer graphics cards and Raspberry Pi Compute Module 4s. So I'm one of the few people that had that combo, and I tried working on the RX 6700 XT, which is a pretty new card. Although now I just found out today that RX 6750 is the new one. So I now have the old 6700 series card. But all the newer ones, like I tried an RX 550 and 580, I think. Those cards all use that newer driver, but the newer driver has a little bit different architecture, and it's harder to work with on the Pi, which has that broken PCI Express implementation. I also tried tons of NVIDIA cards. The first one I tried was the GT710, which is a newer card. Like you can still buy those new today, but it has a buy one PCI Express slot, so you can plug that straight into a Compute Module I/O board, which is cool. A lot of the other cards you have to buy like a riser, and you have to use an external power supply and all these things. With that GT710, it's low power enough, you just plug it right in and start using it. I also tried an NVIDIA 1080, and I think that was the newest NVIDIA card I ever tried, because I don't know, I'm not too much invested in it, but I am more Team Red, mostly because of their open source drivers. So I don't have any newer cards in the NVIDIA realm.
Out of everything that you've tested so far, about how many cards have you seen any level of success with?
4 personally. A few other people have tried other models in that same lineup from AMD. But another interesting card, I think I have it here. Where is it? Yeah. I think that's also in the other room. It's not actually part of the project I'm working on, but that'll come in a week or two. But I have another card. It's an M.2, like an NVMe SSD, those tiny little things. It's a VGA card that uses an SM750 chip with 16 megabytes of VRAM. So all the new GPUs now have like 12 gigabytes or 16 gigabytes of virtual RAM, video RAM. This one has 16 megabytes. It's not really meant for gaming or anything. It's meant for like a server where you need a display and it doesn't have it built into the motherboard. Or it's meant for, I think Linus Tech Tips did a video on this little card last year or a year or two ago, and he's like, it says on the website it's for gaming. It's like, well, not for gaming, like you're not going to play Doom or something. It's for like slot machines. Like if you go in a casino, all those slot machines have a computer inside, and all they really need to do is display 2D graphics. So you don't want to put a $800, NVIDIA card inside of a slot machine. So you put these little M.2 cards, and they can run it that way. So we got that working, but that card, I actually asked. It's from ASRock Rack, and I asked them like, so I'm trying to get this working on the Raspberry Pi, and they're like, yeah, we don't support the Raspberry Pi, sorry. So we hacked around, display output for our console, but that's about all that we got to. The problem is the driver in Linux is also not well maintained, because I don't think too many Linux users care too much about anything besides just having a console or displaying an output. So I don't think we'll get any further with that card. But it did work, which is kind of cool.
So we have a question from a viewer, and actually last week's guest.
Hi, Kevin.
What was the biggest challenge making this work?
Yeah. I mean, the biggest challenge is learning the Linux kernel, learning how graphics drivers work because they're a lot more complicated than a lot of other drivers. Trying to figure out what was going wrong. That took months probably. And at one point I put a call out like, does anybody have a PCI Express debugger that I could borrow? Because we were seeing weird stuff, and here's the problem. Like most of the time with computers, you do something, it fails, and you get like a debug log or a kernel dump or something like that. And so you can look at what failed and then figure out what happened. With these graphics card things, the problem is the memory accesses were so wrong that it would just kill the whole system. Like it would literally, it was not just a lockup, it would just stop. Like everything would just stop and there was no output. We tried debugging with all kinds of different debuggers actually, and none of them were working. So it was like, okay, well, let's look at the hardware level. And I almost got somebody from, I think, AMD to send something, but that was during the pandemic. And during the lockdown, he's like, we have like 2 of these older ones sitting here, and they would work great for me because it's PCI Express Gen 2, the old one that the Pi uses. Now we're up to Gen 5, and Gen 6 is somewhere around the corner and all that. In terms of planning, Gen 4 is probably in most computers, the newest computers today. But the Pi uses Gen 2, so these older programmers aren't being used as much, like at AMD's labs and NVIDIA's labs and wherever else they do PCI Express validation. So the problem is that these things cost tens of thousands of dollars. So I can't just go buy one, no matter how much. I mean, maybe if I get 50 million YouTube subscribers, I could get that kind of budget. But I don't have that budget. So I almost got one sent, but since it was on lockdown, they couldn't get into the building to box it up and send it. So we ended up, somebody was finally able to get a debugger running, a GDB debugger running while the lockup was happening, to the point they could see the memory access that was going on. And that's when we started seeing more from other hardware too, like storage controllers and things, where basically what would happen is we would ask for a 64-bit memory address, and the Pi would spit back a 32-bit address with like zeros for the 64-bit part of the address. And then when you get that, you try accessing the wrong thing and things blow up, and the Pi's not very happy at that point. So then we found out, like, okay, we're going to need to work around this. So everything that tries to get a 64-bit memory address has to use 32 bits. And there are some functions in Linux, like memcopy is the big one, where when you copy memory around, you can't copy the full amount of memory at the same time. So we copy like 1 byte at a time instead of 8 bytes or 16 bytes or whatever. So that's another thing that it's still being worked on for the driver, and we're running into issues now where we can get the window manager to run, so you can boot up a Pi and see it through the graphics card, and you can run like GL gears and other tests and benchmarks, and they kind of run. Some of them better, some of them worse, but some software like Portal and Portal 2 that we're trying to run, the problem is that sometimes they bake in their own version of something, so we can't override the way that it copies memory. So it uses the right way, but we want to use a bad way, and we can't override it as easily. So I know CoreForge is working on that right now. And I don't know if you can add to the description later or something, but there's a link to an issue where if you really love this stuff and you want to try to bend your brain in ways that you never knew it could bend, every detail is being documented in a GitHub issue, and it's up to like 700 comments or 600, I don't know how many. Every time I go there, I have to click like show hidden comments, because now, there's many, many pages of comments on there.
That's great.
That's great. Well, I've got a question for you, Jeff, and it's a short question. Why?
Valid question.
Especially when you consider that.
We can, but come on, why? Why do we need a discrete on a Pi?
Yeah, I mean, there's almost no usable use case for this. At some point, there could be, and I think that's a next step. Right now, the why is because I tried and I failed, and I hate failure, so I'm gonna keep trying. And we got the screen to light up. So at that, like, I'm to the point where I'm satisfied, but it'll be cool if we can go further, because these drivers have things like most of these cards support H.264 encoding. acceleration and decoding acceleration. So that
Yeah.
the Pi can do some of that too, and some other ARM CPUs can do that. But if we could have these cards in a little, like if you have a Pi NAS build and you put a little card in it, one of these older cards that only cost $20 on eBay, you could accelerate the video encoding. And if you get a new enough card, it could do 1080p or maybe even 4K or something like that, and accelerate that so that now it's a much better Plex transcoding box or something. So that's a valid use case. Also, I'm not doing this, but if somebody wanted to go for the world record of how many monitors you connect to a Pi, maybe that could be possible with more video cards or something. But it is nice. Like with the cards I have, I can now plug in HDMI, VGA, DVI, and DisplayPort all into one Pi. So it's interesting. But I think in the long term, it's better because my hope is that this whole experience with not just GPUs but other cards has made Raspberry Pi and also other chip manufacturers realize on cheaper computers. We can build them in very.
Jeff, your audio is going a bit weird, mate.
Oh no! Uh-oh.
Getting a little bit of lag too. I like that answer though. That was absolutely in the spirit of a good Pi project. Why would you do it? Why not? That's right there. And the fact that you have so much community support helping build all of it is just testament to what makes the Raspberry Pi so big. Is it's got a huge community. You're going to find people who want to do it too, even if they don't know why. They're ready to help you figure out how to get this running.
Exactly.
Someone will figure out what to do with it once it is running.
Well, it opens the door as well to other devices being connected to PCIe. So if we get this problem solved, we've got some investigations to sort of mess around with other components. We could have sound cards, we could have network cards, you name it. If it's got PCI Express connection, stick it in, see what happens.
Somebody in the comments asked that if you can pull it up, Avram. I think David Glaude asked what else, what other PCI cards could be interesting to do with the Pi like that.
Yeah. Well, one thing is I have a website called pipci.jeffgeerling.com. I'll stick it in here, pipci.jeffgeerling.com. And that's been one of the things that we're working on as a community is a database of all the different cards that have been tested with a compute module. And like just a couple days ago, somebody emailed me. He said like in the skateboard community, they like to use these certain old Sony DV cameras for the look of the video you get out of them. And so when they get the little mini DV cartridge, the little boxes that you can plug into modern computers cost like $1,000 or $2,000. He wants to take a Raspberry Pi and a FireWire card and build his own little box that can transcode these mini DV tapes into computer usable footage. So that's one use case where it's like instead of having a PC, you can have a little Raspberry Pi and it can be a lot smaller and you could put it into a cheap little old mini DV camcorder. There's also all kinds of other cards that people have used. Uh-oh, it looks like my video is going away or something. Can you still hear me?
Yeah, we see you just fine.
Yep.
I mentioned before this thing started that I was having weird issues with audio and video, which is unusual, but whatever. Maybe my internet connection's bad today.
It'll fix when the podcast is over.
Yeah. So there's plenty of other things too, like networking. You can use a Pi with Wi-Fi 6 or 6E, and I'm actually doing some more testing on that coming up to see
Cool use case.
how much bandwidth we can use. And the cool thing is like the Pi's built-in Wi-Fi gets up to like 100 or 120 megabits, but with Wi-Fi 6 and a little M.2 card that's like this big, you could build a Raspberry Pi Wi-Fi interface that gets over a gigabit of speed over wireless. And that's with like a consumer Wi-Fi 6 router. I actually am going to be doing some 6E testing to see if I can get a lot more than a gigabit over wireless. And that'll be pretty fun.
Oh, cool.
But you can build simple routers with Raspberry Pis. You can build access points, although some of the Wi-Fi 6 chips don't work as well with the drivers, and Intel's chips especially don't work as well. So that's something that's interesting, but unless you're really dedicated, you're not going to do that. But there are some other products out there that use all these capabilities to build a device that's a lot cheaper than and also more energy efficient than something off the shelf that's an old PC or something.
That makes sense. So, let's see. Did we ask, have you come across drivers and it's quite obvious that in their current state they would never work on anything?
The thing that we've seen a lot with these drivers for cards is a lot of times they're programmed for one specific use case, and they're not built to be flexible. I know that, like, I started out as a programmer in my life, and so you can either make something generic and it works a lot of places, but it takes a lot longer to build that and to test it well and to make sure that not only is it generic, but it also solves your problem. Or you can make it extremely specific and solve your one problem and then just move on. A lot of companies are not going to put in the extra effort to say, oh, we're building a Linux open source driver. We want it to be as awesome and compatible as possible. They're going to say, we have a customer with this server in their data center, and it's only one model, and we need to make sure it works on that server, and then we're going to call it done. And that's kind of like the way the SM750 driver seems to be. It was built to work in basically like a server use case as a little VGA output for your server. And that's about it. Like it's not built to, it wasn't really updated to work with the newer standards in Linux with the DRM subsystem. And it's not really maintained, but it works. So, that's how a lot of drivers seem to be. There are some companies that seem to invest a lot more in making their drivers good. And also, some companies that see the value in the ARM architecture and even RISC-V nowadays. And so they build their drivers to be really generic, and they care about, like, oh, it doesn't work on the Pi. Well, we can modify this and that and give a patched version. A lot of times they're not going to publish that patched version for everybody, because if they're making one little bug fix for the Raspberry Pi's broken PCI Express bus, they don't want that bug fix to affect any other hardware. So Broadcom is one of the companies with their storage controllers that actually let me share the patch that helps their driver work. So you can't install their patch from their website and have it work, but you can get one of their storage cards working on the Pi.
Interesting. So speaking of things that work on the Pi, this week we've seen more effort to bring 8-bit computing. Not that there wasn't any effort before to Pi.
Indeed, yes. So you can probably guess from the T-shirt, this is 16-bit, the Amiga, Commodore Amiga, but I'm a child of the 8-bit era. So I started off, and I've got the props as well as a Fender guitar just next to it, which we're all comparing before the show. So we've all got guitars behind us. So this was my second computer. Not this exact model. This is what I got off eBay about 2 years ago. But the Commodore 64 was my second computer. The first one was Commodore 16. And this pretty much changed how I did everything in my life. I went from playing games to writing code. And the code that I wrote with this machine, he says, putting it down very carefully, not to knock the guitar, was basic. These are the Osborne books. These were really popular when I was a kid. And they're quite popular now. You can get PDFs of them. So it tells you how to program in BASIC. It's all lovely color-coded stuff.
Oh,
yeah,
that's cool.
They're awesome. As you can get free PDFs on the Osborne website. Just search for Osborne BASIC 1980s books, and you'll find them. Great to play around with. But I still mess around with BASIC. So I've been messing around with BASIC now for decades. And I found a new device that supports it. And it's something that's been on my desk for ages. So I'm going to show you what it is.
You better.
I better. There you go. That's when OBS lets me. There we go. So, Raspberry Pi Pico. $4 microcontroller. Okay, I'm cheating a little bit. It's in Citron's Maker Pi Pico, which is about $10 roughly, just because it's easier for wiring for the demo. That's running a version of BASIC right now, and it's running a version of BASIC called Pico Mite. I probably butchered the word there. Basic interpreter for Raspberry Pi Pico. You just load the UF2 firmware onto the device, and it behaves as if it's a computer from the 1980s running BASIC. So I can type in commands and have cool stuff happen. So that's what I've been doing this afternoon. I really should have been working, but I did this instead. So,
Jeff, are you commenting in the comments of your own live stream?
Of course.
He also has the little board you've got there. Les.
Yeah.
Nice.
They sent it to me a few months
Nice.
ago. I never got to review it, but I was like, man, this is so much better than soldering header pins and a bunch of jumper wires and things. So
They are great, and the Grove connections on the edge are really good. It's really handy for stuff to plug in and away you go. But right now, this board is running BASIC, so beginner's all-purpose symbolic instruction code. And I've got, let's see, Flash list, if I remember correctly. I've got 4 programs on, only one of which works, I'll hasten to add. So I'm going to load that one. It'll make a better demo. So Flash load 3. So program 3, LED blink and sound. So if I type in list, I can show you what's happening with the code. But the top line is a comment, and that's really the name of the application. So LED blink and sound. I set 6 pins, or is it 7? 7 pins. Let's try and count. There we go. Pins, or is it 8? I'll get it right one day. So 0 to 6 and pin 18 are all digital outputs. There's a delay of 100 milliseconds, and then I start a loop. So that's a label in BASIC. You can use the numbers where you go 10, print, 20, go to 10, that sort of thing. But I'm just using this right now. I'm using a label to denote where the loop starts. I then pause. I then start the loop with turning pin 0 on. So set it to 1. Pause for 100 milliseconds. And then I go through each of the pins and saying turn that one off, turn this one on, have a delay. And then it'll go all the way to pin 18. And pin 18 is connected to a buzzer. That'll beep. And I'll go back to the start where the loop starts. So pin 1, or pin 0 comes on again. And it's really easy to mess around with. So the demo's running now. If I go to the big camera, you can see it a bit clearer. You should hear it noise. Really annoying. It's like a bat trying to find something.
It sounds like a mechanical keyboard.
There you go. It's a Cherry MX Blue. But that's BASIC controlling the GPIO. Now, it's not just digital outputs. I can use inputs, so I can read a button. I can use analog input, so I can measure voltage on a device like a potentiometer on it or a light-dependent resistor. And I've also been looking through the manual today. There's a 170-page manual for this, covering everything you could think of in BASIC. But it can also work with ultrasonic sensors, so HC SR04 sensors, and it can work with neopixels. So I can program in BASIC neopixels, and that's my goal for a how-to. I want neopixels with BASIC. That'd be cool. And Bornark, no, there's no line numbers. I can see in the comments. I'm using a label instead. But you can use line numbers if you wish.
Watch out, Circuit Python.
You can run BASIC in CircuitPython. There's a version called Pi Basic. Anne Barella mentioned it a while ago. It really just is like a Python interpreter interpreting back to BASIC, and then it spits out BASIC through Python. It's weird, but it's great fun. It just works. Just copy the file straight on pibasic.py, import it, and away you go.
That is too cool.
Wow. That, once again, even more ways for us to do emulation of older technologies. Speaking of older technologies, Ash, you've gotten the benchmark of old technologies to run.
Oh yeah, since we're hyped about graphics, I wanted to take some time today to share with our lovely audience how to set up Doom on the Raspberry Pi. So many of you know, but for those who don't, the team at ID Software released the source code for Doom years ago, which makes it easy for people to tinker with and play with, and as Avram said, use as a benchmark. So what I want to share with you guys today is how to set up an engine that can run the game on the Pi. Specifically, this port is known as Chocolate Doom. This is kind of like a car without gas, and by that I mean it has everything you need to get going except the meat and potatoes, the actual game assets and levels, things like that. When it comes to emulating Doom or playing Doom, the game data is referred to as WAD files, W-A-D. I might not be pronouncing that right. It sounds like WAD, like what you do with a piece of paper. So if you've ever seen any crazy Doom ports where they've changed the monsters out with maybe a funny character or some wacky sound effects, what those people are doing is they're editing the WAD file to have like a custom asset pack. So what I'm going to show you guys is how to set up the engine, but as far as finding the actual game assets go, that's kind of on you, but I will point you to a place you can go to find a quick demo to check it out. So installing it is easy enough. You want to update your Pi and you want to run a command to get it installed, which is just sudo apt install chocolate-doom. And you will have to hit yes for that install. Let me switch my display over so you can see I've got a virtual machine running here with Raspberry Pi OS. And I've already got chocolate-doom set up and installed. So for today's demonstration, I'm going to run a little demo shared by the team over at Pi My Life Up. However, like I said, you can find tons of options online if you do a little research for Doom WAD files. So you'll need to unpack your WAD file into a custom folder and point chocolate-doom to the folder that has the file you want to use in the game when running the engine. So let me pull up my VM. I almost clicked it in OBS. That doesn't work. I have to actually open the VM. Here we go. So you can see it starts off chocolate-doom. You're telling it to run a specific WAD file, and then there's the location of the demo that I'm running. I'm just going to hit enter, and away we go. Here's what it looks like. I know you guys can't hear it, but it got really loud in my ears just now. So we can move between menu options. I can get it started. Nightmare mode, why not? Let me in. And here we go. Boom, boom. I'm playing Doom. Let me close out of this because if you all are talking, I can't hear you. It's so loud. There we go. So
Nice.
That is Doom on the Raspberry Pi. It's really easy to get started with. Just look up chocolate-doom. You'll find everything you need. What do you guys think? Have you played Doom lately? And what is the craziest thing that you've seen it run on?
We can do the joke and say pregnancy test.
Yeah, that one was on my mind too.
We found out it was just a video stream going across, wasn't it? A very low-res video stream going to it. But it's amazing what you can run Doom on. We've had it on a Pico a few weeks back, and that was fantastic. But going back to WADs, or however they're pronounced, my favourite is a one that came out late 90s, which was Aliens, based on Colonial Marines and LV-426, and that, yes, I'm an Alien fan. And it was genuinely scary. It was great.
Oh, cool. I've not seen that one. What about you, Avram?
I mean, I haven't run it a lot lately. It's more in this house trying to get Minecraft to run on various devices. But
that's another new benchmark, isn't it?
Yeah, I mean, it's not as low level as Doom, right? I don't think you could run Minecraft on a Pico or anything like that.
We did get Minecraft running on the 54 or 6450 at 1 frame per second.
No.
There's some performance on the table there. The problem is that when you copy memory at 1 byte per cycle, that's not very fast. So,
you know, my 10-year-old would probably play it at the 1 frame a second just because he just wants to try Minecraft in every possible way that it can be played. So he's played it in ways where I said, hey, this isn't getting a good frame rate. That's okay. I can still play it at 10 FPS or something.
Kevin, that's a great question. Probably.
The person to ask me, Martin O'Hanlon, because I remember he did some Minecraft games that he programmed. Sorry, he made some games in Minecraft, like a giant version of Snake, which was awesome. You had the controls on the ground and the whole Snake board was above you like some sort of monolith.
Wow. That's too cool. I like how easy it is to like build computers using Redstone and stuff like that. Because all you need is a 1 and a 0 to get started. And once somebody sets the framework, anybody can pick it up and keep building.
Yeah, that's great. So it's just amazing what Jeff has accomplished here. Yet
Definitely.
Another opportunity to really push the envelope of what Pi can do. So thank you so much, Jeff, for coming on, sharing that with everyone. And we can't wait to see how this progresses to the next level. Well, as always, we are here every Tuesday at 7:30 p.m. UK time, 2:30 p.m. Eastern, and we will see everyone next week. Bye, everyone.